Alright, let's move on to our next set of questions. Question 81. You are migrating your on-premises solution to Google Cloud in several phases. You will use Cloud VPN to maintain a connection between your on-premises systems and Google Cloud until the migration is completed. You want to make sure all your on-premises systems remain reachable during this period. How should you organize your networking in Google Cloud? A. Use the same IP range on Google Cloud as you use on-premises. B. Use the same IP range on Google Cloud as you use on-premises for your primary IP range and use a secondary range that does not overlap with the range you use on-premises. C. Use an IP range on Google Cloud that does not overlap with the range you use on-premises. D. Use an IP range on Google Cloud that does not overlap with the range you use on-premises for your primary IP range and use a secondary range with the same IP range as you use on-premises. Okay, this is a fundamental network planning question for any hybrid cloud migration. The key to this problem is understanding how network routing works when you connect two different networks, like your on-premise data center and a Google Cloud VPC, using a VPN. The most important rule is that the IP address ranges on both sides of the connection must be unique. If both your on-premise network and your GCP network use the same IP range, the routers won't know where to send the traffic, leading to routing conflicts that break the connection. With that rule in mind, let's look at options A, B, and D. All of these options suggest using an IP range on Google Cloud that is the same as, or overlaps with, the on-premise range in either the primary or secondary range. Any overlap will cause the routing conflicts we just described, which violates the requirement to keep all systems reachable. Therefore, all of these options are incorrect. This brings us to option C, which is the correct answer. This describes the standard best practice for hybrid networking. By choosing an IP range on Google Cloud that does not overlap with your on-premise range, you ensure that every address is unique across the entire connected network. This allows routers to correctly send traffic to the right destination, whether it's in the cloud or on-premise, ensuring a stable and reliable connection for your migration. Therefore, the way you should organize your networking is C. Use an IP range on Google Cloud that does not overlap with the range you use on-premises. Question 82. You have found an error in your App Engine application caused by missing Cloud Data Store indexes. You have created a YAML file with the required indexes and want to deploy these new indexes to Cloud Data Store. What should you do? A. Point Cloud Data Store create indexes to your configuration file. B. Upload the configuration file to App Engine's default cloud storage bucket and have App Engine detect the new indexes. C. In the GCP console, use Datastore admin to delete the current indexes and upload the new configuration file. D. Create an HTTP request to the built-in Python module to send the index configuration file to your application. Okay, this is a very practical question about managing Cloud Data Store when you're using it with App Engine. The situation is that your application needs new indexes to run its queries, and you've already defined them in a YAML file. The task is to get that configuration file deployed. With that in mind, let's look at our options. Let's look at option B, uploading the file to a cloud storage bucket. This is incorrect because App Engine and Datastore don't automatically monitor a storage bucket for new index configurations. Simply uploading the file won't do anything. Next, option C suggests using the Datastore admin in the GCP console. While you can manage indexes there, the process described is flawed. There isn't a direct upload configuration file option for deployment, and deleting your current indexes before adding new ones is unnecessary and could cause problems. Option D, creating an HTTP request from your application, is also incorrect. Deploying indexes is an administrative task that you do from outside your application. It's not something the application code itself should be doing. This brings us to option A, which is the correct and standard method. The Cloud Command Line tool is designed for managing all of your Google Cloud resources. It has a specific command, Cloud Data Store Create Indexes, which is built for this exact purpose. You run this command from your local machine and point it to your local YAML configuration file. The tool then handles the process of deploying those new indexes to your Cloud Data Store instance. Therefore, the correct thing to do is A. Point Cloud Data Store Create Indexes to your configuration file. Question 83. You have an application that will run on Compute Engine. You need to design an architecture that takes into account a disaster recovery plan that requires your application to fail over to another region in case of a regional outage. What should you do? Deploy the application on 2 Compute Engine instances in the same project but in a different region. Use the first instance to serve traffic, and use the HTTP load balancing service to fail over to the standby instance in case of a disaster. B. Deploy the application on a Compute Engine instance. Use the instance to serve traffic, and use the HTTP load balancing service to fail over to an instance on your premises in case of a disaster. C. Deploy the application on 2 Compute Engine instance groups, each in the same project but in a different region. Use the first instance group to serve traffic, and use the HTTP load balancing service to fail over to the standby instance group in case of a disaster. D. Deploy the application on 2 Compute Engine instance groups, each in a separate project and a different region. Use the first instance group to serve traffic, and use the HTTP load balancing service to fail over to the standby instance group in case of a disaster. Okay, this is a question about designing a high availability and disaster recovery architecture on Google Cloud. The main requirement is that the application must be able to survive a complete regional outage by failing over to another region. With that in mind, let's evaluate our options. Let's start with option A. This is incorrect because it suggests using single, standalone Compute Engine instances. For a critical application, you should always use managed instance groups, which provide essential features like auto-scaling and self-healing. A single instance is a single point of failure. Option B is also incorrect for the same reason. It uses a single instance. Additionally, failing over from the cloud back to an on-premise data center is a much more complex and generally less desirable disaster recovery strategy. Next, let's look at option D. While it correctly uses instance groups in different regions, it suggests placing them in separate projects. This adds unnecessary complexity to the management of the application and the load balancer. The standard best practice is to keep all the resources for a single application within the same project for easier governance. This brings us to option C, which is the correct and recommended architecture. It uses 2 Compute Engine instance groups, which provides scalability and self-healing. Placing these instance groups in different regions is the key to providing disaster recovery against a regional failure. Finally, using a global HTTP load balancing service is the perfect tool to manage this setup. The load balancer can distribute traffic between the 2 regions and will automatically fail over by directing all traffic to the healthy region if the other one goes down. Therefore, the best way to design this architecture is C. Deploy the application on 2 Compute Engine instance groups, each in the same project but in a different region, and use the HTTP load balancing service to fail over. Question 84. You are deploying an application on App Engine that needs to integrate with an on-premises database. For security purposes, your on-premises database must not be accessible through the public internet. What should you do? Deploy your application on App Engine standard environment and use App Engine firewall rules to limit access to the open on-premises database. B. Deploy your application on App Engine standard environment and use Cloud VPN to limit access to the on-premises database. C. Deploy your application on App Engine flexible environment and use App Engine firewall rules to limit access to the on-premises database. D. Deploy your application on App Engine flexible environment and use Cloud VPN to limit access to the on-premises database. Okay, this question is about hybrid cloud networking, specifically how to connect a serverless application on App Engine to a private on-premise database. The 2 key parts to this are choosing the right App Engine environment and the right networking solution. With that in mind, let's evaluate our options. Let's start by looking at options A and B, which both suggest using the App Engine standard environment. Both of these are incorrect because the standard environment runs in a sandboxed environment and cannot directly connect to a VPC network. This means it cannot use a Cloud VPN to reach your on-premise resources. Next, let's look at option C. While it correctly identifies the App Engine flexible environment, it suggests using firewall rules to protect an on-premise database that is open to the public internet. This is a very bad security practice and directly violates the requirement that the database must not be accessible publicly. This brings us to option D, which is the correct and most secure architecture. First, it uses the App Engine Flexible Environment. This is critical because the flexible environment deploys your application inside your project's VPC network. Second, by being in a VPC, your application can then use a cloud VPN to establish a secure, private tunnel to your on-premise data center. This allows your App Engine application to communicate with your database using private IP addresses, completely isolated from the public internet, which fulfills all the requirements of the question. Therefore, the correct solution is D. Deploy your application on App Engine Flexible Environment and use Cloud VPN to limit access to the on-premises database. Question 85. You are working in a highly secured environment where public internet access from the Compute Engine VMs is not allowed. You do not yet have a VPN connection to access an on-premises file server. You need to install specific software on a Compute Engine instance. How should you install the software? A. Upload the required installation files to cloud storage. Configure the VM on a subnet with a private Google Access subnet. Assign only an internal IP address to the VM. Download the installation files to the VM using SUDL. B. Upload the required installation files to cloud storage and use firewall rules to block all traffic except the IP address range for cloud storage. Download the files to the VM using SUDL. C. Upload the required installation files to cloud source repositories. Configure the VM on a subnet with a private Google Access subnet. Assign only an internal IP address to the VM. Download the installation files to the VM using cloud. D. Upload the required installation files to cloud source repositories and use firewall rules to block all traffic except the IP address range for cloud source repositories. Download the files to the VM using SUDL. Okay, this is a network security question that deals with a common scenario. How do you get files onto a virtual machine that has no public internet access? The solution needs to be secure and use Google Cloud's native features. With that in mind, let's look at our options. Let's start by looking at the options that use the wrong tools or methods. Options C and D suggest using cloud source repositories. This is not the ideal place to store installation files. Cloud storage is designed for that. They also suggest using incorrect command line tools for that service. Option B suggests using firewall rules to allow traffic to a specific IP address range for cloud storage. This is an outdated and less secure approach. Those IP ranges can change, and the modern, recommended way to handle this is with a feature called Private Google Access. This brings us to option A, which is the correct and most secure solution. It follows a perfect, four-step process. First, you upload the installation files to cloud storage, which is the right service for storing files. Second, you ensure your VM is on a subnet that has private Google Access enabled. This is the key feature that allows a VM with only a private, internal IP address to reach Google's APIs and services, like cloud storage, over Google's internal network. Third, you ensure the VM only has an internal IP, which meets the security requirement. Finally, from the VM, you can use the SUDL command to securely download the files from your cloud storage bucket. Therefore, the best way to install the software is upload the required installation files to cloud storage, configure the VM on a subnet with a private Google Access subnet, assign only an internal IP address to the VM, and download the installation files to the VM using SUDL. Question 86. Your company is moving 75 terabytes of data into Google Cloud. You want to use cloud storage and follow Google recommended practices. What should you do? Move your data onto a transfer appliance. Use a transfer appliance rehydrator to decrypt the data into cloud storage. B. Move your data onto a transfer appliance. Use Cloud Data Prep to decrypt the data into cloud storage. C. Install SUDL on each server that contains data. Use resumable transfers to upload the data into cloud storage. D. Install SUDL on each server containing data. Use streaming transfers to upload the data into cloud storage. Okay, this is a data migration question. The most important piece of information here is the size of the data, 75 terabytes. For such a large amount of data, the method of transfer becomes critical. With that in mind, let's look at our options. Let's start with options C and D. which both suggest using the SUDL command line tool. While SUDL is the standard tool for interacting with cloud storage, it's not the recommended practice for transferring a dataset of this massive size. Trying to upload 75 terabytes over a standard internet connection would be incredibly slow and could take weeks or even months, and would be prone to network failures. Next, let's look at option B. It correctly identifies that a transfer appliance is needed, but it suggests using Cloud Data Prep to decrypt the data. This is incorrect. Cloud Data Prep is a service for cleaning and preparing data for analysis, not for handling the ingestion process from a hardware appliance. This brings us to option A, which is the correct and Google-recommended solution for large-scale data transfers. The process involves using a transfer appliance. This is a physical piece of hardware that Google ships to your data center. You load your 75 terabytes of data onto it locally, and then ship it back to Google. At the Google Data Center, they use a specific tool called the Transfer Appliance Rehydrator to securely decrypt and upload your data into your cloud storage bucket. This offline transfer method is much faster and more reliable than trying to send that much data over the internet. Therefore, the Google recommended practice for this scenario is a move your data onto a transfer appliance and use a transfer appliance rehydrator to decrypt the data into cloud storage. Question 87. You have an application deployed on Google Kubernetes Engine using a deployment named Echo Deployment. The deployment is exposed using a service called Echo Service. You need to perform an update to the application with minimal downtime to the application. What should you do? Use kubectl set image deployment / echo deployment / new image / B. Use the rolling update functionality of the instance group behind the Kubernetes cluster. C. Update the deployment YAML file with the new container image. Use kubectl delete deployment / echo deployment and kubectl create f / YAML file / D. Update the service YAML file with the new container image. Use kubectl delete service / echo service and kubectl create f / YAML file /. Okay, this is a very common and fundamental question about managing applications on Kubernetes. The key requirement here is to perform an update with minimal downtime, which means we need to use a method that keeps the application available while the update is in progress. With that in mind, let's look at our options. Let's start with option B, which suggests using the rolling update feature of the underlying instance group. This is incorrect because application updates in Kubernetes are managed at the Kubernetes level by a deployment, not at the infrastructure level of the virtual machine instance group. Next, option C suggests deleting the old deployment and then creating a new one. This is a bad approach because the kubectl delete command will immediately terminate all the running pods of your application, causing a complete outage. This directly violates the minimal downtime requirement. Option D is also incorrect. A Kubernetes service is a networking resource that directs traffic to your application pods. It doesn't know anything about the container image version. Changing the service will not update your application. This brings us to option A, which is the correct and recommended method. The kubectl set image command tells the Kubernetes deployment to update the container image to a new version. When it receives this command, the deployment automatically performs a rolling update. It will carefully bring up new pods with the new image, and only once they are healthy will it start terminating the old pods. This process ensures that there are always live, healthy pods serving traffic, which results in a zero downtime deployment. Therefore, the best way to perform this update is A. Use kubectl set image deployment / echo deployment, new image. Question 88. Your company is using BigQuery as its enterprise data warehouse. Data is distributed over several Google Cloud projects. All queries on BigQuery need to be billed on a single project. You want to make sure that no query costs are incurred on the projects that contain the data. Users should be able to query the datasets but not edit them. How should you configure users' access roles? A. Add all users to a group. Grant the group the role of BigQuery user on the billing project and BigQuery data viewer on the projects that contain the data. B. Add all users to a group. Grant the group the roles of BigQuery Data Viewer on the billing project and BigQuery User on the projects that contain the data. C. Add all users to a group. Grant the group the roles of BigQuery Job User on the billing project and BigQuery Data Viewer on the projects that contain the data. D. Add all users to a group. Grant the group the roles of BigQuery Data Viewer on the billing project and BigQuery Job User on the projects that contain the data. Okay, this is a question about identity and access management and billing in BigQuery. The goal is to set up a specific access pattern where data is stored in many projects, but all the query costs are consolidated into a single central project, and users can only read the data. To solve this, you need to understand two key BigQuery roles. The BigQuery Job User role gives permission to run a query, and the project where this role is granted is the one that gets billed for the query's cost. The BigQuery Data Viewer role gives permission to read the data in a dataset. By combining these two roles on different projects, we can achieve our goal. With that in mind, let's look at our options. Let's look at option A and B first. Both suggest using the BigQuery User role. This role is too powerful as it allows users to create and delete datasets, which violates the requirement that users cannot edit the data. So, both of these are incorrect. Next, let's look at option D. This option has the roles assigned to the wrong projects. Granting Job User on the data projects would cause the query costs to be billed to those data projects, which is the opposite of what we want. Granting Data Viewer on the billing project serves no purpose. This brings us to option C, which describes the correct and recommended configuration. First, you grant the BigQuery Job User role on the central billing project. This gives your users the ability to run queries and ensures that project pays for them. Second, you grant the BigQuery Data Viewer role on all the different projects that contain the data. This gives the same users read-only access to that data. This setup perfectly separates the permissions and centralizes the billing as required. Therefore, the correct way to configure the access roles is C. Grant the group the roles of BigQuery Job User on the billing project and BigQuery Data Viewer on the projects that contain the data. Question 89. You have developed an application using CloudML Engine that recognizes famous paintings from uploaded images. You want to test the application and allow specific people to upload images for the next 24 hours. Not all users have a Google account. How should you have users upload images? Have users upload the images to cloud storage. Protect the bucket with a password that expires after 24 hours. B. Have users upload the images to cloud storage using a signed URL that expires after 24 hours. C. Create an App Engine web application where users can upload images. Configure App Engine to disable the application after 24 hours. Authenticate users via cloud identity. D. Create an App Engine web application where users can upload images for the next 24 hours. Authenticate users via cloud identity. Okay, this is a question about providing secure, temporary access to Google Cloud resources for users who might not have Google accounts. The key requirements here are that the access must expire after 24 hours and it must work for people without a Google account. With that in mind, let's look at our options. Let's start with option A, which suggests protecting a cloud storage bucket with a password. This is incorrect because cloud storage doesn't have a feature to password protect buckets. It uses IAM and other mechanisms for security. Next, let's look at options C and D. Both suggest building an App Engine web application and authenticating users with cloud identity. These are incorrect because the question explicitly states that not all users have a Google account. Cloud identity is based on Google accounts, so this solution would not work for everyone. Also, building a custom web app is a much more complex solution than what is needed here. This brings us to option B, which is the correct and recommended solution. A signed URL is a special feature of cloud storage that lets you create a time-limited, unique URL that grants temporary permission to upload or download a file. You can set the expiration to 24 hours. Most importantly, anyone who has this URL can use it without needing to have a Google account. This is a secure, simple, and effective way to meet all the requirements of the question. Therefore, the best way to have users upload images is B. Have users upload the images to cloud storage using a signed URL that expires after 24 hours. Question 90. Your web application must comply with the requirements of the European Union's General Data Protection Regulation, GDPR. You are responsible for the technical architecture of your web application. What should you do? Ensure that your web application only uses native features and services of Google Cloud Platform, because Google already has various certifications and provides a pass-on compliance when you use native features. B. Enable the relevant GDPR compliance setting within the GCP console for each of the services in use within your application. C. Ensure that Cloud Security Scanner is part of your test planning strategy in order to pick up any compliance gaps. D. Define a design for the security of data in your web application that meets GDPR requirements. Okay, this is a question about legal and regulatory compliance, specifically the GDPR in a cloud environment. The key to answering this correctly is to understand the shared responsibility model. This model means that while Google ensures their underlying cloud infrastructure is compliant with regulations like GDPR, you, as the customer, are still responsible for ensuring that the application you build and the data you handle on top of that infrastructure are also compliant. Google gives you the tools, but you have to use them correctly. With that in mind, let's look at our options. Let's look at option A. This is incorrect because it's based on the misunderstanding that you can just pass on compliance responsibility to Google. That's not how it works. You are always responsible for your own application's compliance. Next, option B is incorrect. There is no simple GDPR compliance setting you can just turn on in the GCP console. Achieving compliance is a comprehensive process involving your application's architecture and data handling, not just a single checkbox. Option C suggests using Cloud Security Scanner. While this is a helpful tool for finding some types of security vulnerabilities, it is not a complete GDPR compliance tool. GDPR covers a wide range of requirements beyond what a technical vulnerability scanner can check. This brings us to option D, which is the correct answer. The primary responsibility of a technical architect in this situation is to proactively define a design for the security of data that meets the specific requirements of the GDPR. This involves making architectural decisions about data encryption, access controls, data retention policies, and ensuring the rights of data subjects are protected within the application itself. It is your responsibility to design for compliance. Therefore, the correct thing to do is D. Define a design for the security of data in your web application that meets GDPR requirements. Question 91. You need to set up Microsoft SQL Server on GCP. Management requires that there's no downtime in case of a data center outage in any of the zones within a GCP region. What should you do? A. Configure a Cloud SQL instance with high availability enabled. B. Configure a Cloud Spanner instance with a regional instance configuration. C. Set up SQL Server on Compute Engine, using always-on availability groups using Windows failover clustering. Place nodes in different subnets. D. Set up SQL Server always-on availability groups using Windows failover clustering. Place nodes in different zones. Okay. This is a question about designing a high-availability architecture for a Microsoft SQL Server database that you are managing yourself on Google Compute Engine. The most important requirement is that the database must survive the failure of an entire data center, which is called a zone in Google Cloud. With that in mind, let's evaluate our options. Let's start with option A, which suggests using the Managed Cloud SQL Service. While Cloud SQL for SQL Server does have a high availability option, the other answers point towards a solution where you are managing the SQL Server yourself on Compute Engine instances. Next, option B suggests using Cloud Spanner. This is incorrect because the question specifically requires setting up Microsoft SQL Server. Cloud Spanner is a completely different database service. Let's look at option C. This option correctly identifies the right Microsoft technologies, always on availability groups and Windows failover clustering. However, it makes a critical mistake by suggesting you place the nodes in different subnets. Placing servers in different subnets doesn't guarantee they are in different physical locations. To protect against a data center failure, you must place them in different zones. This brings us to option D, which is the correct and complete solution. It uses the right combination of technology and infrastructure design. You use Microsoft's standard technologies, always on availability groups and Windows failover clustering, to create the database cluster. Then, and this is the key part, you place the nodes in different zones. By distributing the members of your cluster across different physical data centers within a region, you ensure that if one zone fails, the database can automatically fail over to a node in a healthy zone, meeting the requirement for no downtime during a zonal outage. Therefore, the correct way to design this solution is D. Set up SQL Server always on availability groups using Windows failover clustering and place the nodes in different zones. Question 92. The development team has provided you with a Kubernetes deployment file. You have no infrastructure yet and need to deploy the application. What should you do? Use Cloud to create a Kubernetes cluster. Use Deployment Manager to create the deployment. B. Use Cloud to create a Kubernetes cluster. Use kubectl to create the deployment. C. Use kubectl to create a Kubernetes cluster. Use Deployment Manager to create the deployment. D. Use kubectl to create a Kubernetes cluster. Use kubectl to create the deployment. Okay, this question is about the fundamental workflow for deploying an application on Google Kubernetes Engine. It's important to know which tool to use for which step, creating the infrastructure versus managing the application inside it. With that in mind, let's look at our options. Let's start by looking at options C and D, which both suggest using kubectl to create the Kubernetes cluster. This is incorrect. The kubectl command is used to talk to a Kubernetes cluster that already exists. It cannot create the underlying cloud infrastructure, like the virtual machines and networking, that make up the cluster. The cloud tool is used for that. Now let's look at option A. It correctly states that you use Cloud to create the cluster. However, it then suggests using Deployment Manager to create the deployment. This is not the standard or recommended approach. While Deployment Manager is an infrastructure as code tool for GCP, the native tool for managing resources inside a Kubernetes cluster is kubectl. This brings us to option B, which describes the correct, standard workflow. The process has two steps. First, you use the Cloud command line tool to create the Google Kubernetes Engine cluster itself, as the cluster is a Google Cloud resource. Second, once your cluster is up and running, you use the standard Kubernetes command line tool, kubectl, to apply your deployment file and create the application resources inside that cluster. Therefore, the correct procedure is B. Use Cloud to create a Kubernetes cluster, and use kubectl to create the deployment. Question 93. You are designing an application for use only during business hours. For the minimum viable product release, you'd like to use a managed product that automatically scales to 0 so you don't incur costs when there is no activity. Which primary compute resource should you choose? A. Cloud Functions. B. Compute Engine. C. Google Kubernetes Engine. D. App Engine Flexible Environment. Okay, this is a question about choosing the right compute service for cost optimization. The most important requirement here is that the service must scale to 0, which is a key characteristic of serverless computing. This means you should pay absolutely nothing when your application is not being used. With that in mind, let's look at our options. Let's start with option B, Compute Engine. This is incorrect. Compute Engine provides virtual machines, and you are billed for them as long as they exist, even if they are idle. It does not automatically scale to 0. Next, option C, Google Kubernetes Engine. This is also incorrect. While you can configure GKE to scale its worker nodes down, you are still charged for the cluster's control plane. It doesn't offer a true scale to 0 cost model. Option D is the App Engine Flexible Environment. This is a common point of confusion, but the flexible environment is designed to always keep at least one instance running to serve traffic quickly. Because an instance is always running, it does not scale to 0 and will always incur costs. This brings us to option A, which is the correct answer. Cloud Functions is a fully managed, serverless product. Its pricing is based on the number of times your code is executed. If no one is using your application, your functions are not being triggered, and therefore you are billed 0. This is the definition of a service that scales to 0, making it the perfect choice for an application that is only used during specific hours. Therefore, the primary compute resource you should choose is a Cloud Functions. Question 94. You are creating an App Engine application that uses Cloud Data Store as its persistence layer. You need to retrieve several root entities for which you have the identifiers. You want to minimize the overhead in operations performed by Cloud Data Store. What should you do? A. Create the key object for each entity and run a batch get operation. B. Create the key object for each entity and run multiple get operations, one operation for each entity. C. Use the identifiers to create a query filter and run a batch query operation. D. Use the identifiers to create a query filter and run multiple query operations, one operation for each entity. Okay, this is a question about performance optimization when retrieving data from Cloud Data Store. The most important clues are that you already have the identifiers for the entities you need, and you want to minimize operational overhead. To solve this, it's important to understand two key differences in Data Store: the difference between a get and a query, and the difference between a single operation and a batch operation. A get is a direct lookup by a unique key, which is very fast. A query is a search that has to scan indexes, which is slower. A batch operation lets you request many items in one single trip to the database, which is much more efficient than making many separate trips. With that in mind, let's look at our options. Let's look at option D, which suggests running multiple query operations. This is the least efficient method because it uses the slower query approach and combines it with the high overhead of multiple separate requests. Option C is slightly better because it uses a batch query, but it's still incorrect. Using a query when you already know the exact keys is inefficient compared to a direct get operation. Next, let's look at option B. It correctly uses the faster get operation, but it suggests running multiple separate operations. This is not optimal as it creates a lot of unnecessary network traffic and overhead. This brings us to option A, which is the correct and most efficient solution. It combines the best of both worlds. You create the key object for each entity you need, and then you retrieve all of them at once using a single batch get operation. This uses the fastest lookup method and the most efficient request method, which directly minimizes the operational overhead as required. Therefore, the best way to retrieve the entities is a create the key object for each entity and run a batch get operation. Question 95. You need to upload files from your on-premises environment to cloud storage. You want the files to be encrypted on cloud storage using customer-supplied encryption keys. What should you do? A. Supply the encryption key in a.boto configuration file. Use SUDL to upload the files. B. Supply the encryption key using Cloud Config. Use SUDL to upload the files to that bucket. C. Use SUDL to upload the files and use the flag encryption key to supply the encryption key. D. Use SUDL to create a bucket and use the flag encryption key to supply the encryption key. Use SUDL to upload the files to that bucket. Okay, this is a question about data security in cloud storage. The specific requirement is to use customer-supplied encryption keys, or CSEK, when uploading files. This means you provide the key, and Google uses it to encrypt your data but does not store the key itself. The key to this question is knowing how to provide that custom key to the SUDL command line tool. With that in mind, let's look at our options. Let's start by looking at options C and D. Both suggest using an encryption key flag directly in the SUDL command. This is incorrect because the SUDL command simply does not have a flag with that name. You cannot provide the key directly as a command line argument in this way. Next, option B suggests using Cloud Config. This is also incorrect. The Cloud Config command is for setting properties for the cloud tool itself, not for passing sensitive information like an encryption key to the separate SUDL tool. This brings us to option A, which is the correct and recommended method. The SUDL tool is configured using a special file called the .boto configuration file. To use a customer-supplied encryption key, you specify the key's details within this file. When you then run sudo to upload your files, it will automatically read the key from the configuration file and use it to encrypt your data as it's sent to cloud storage. This is the standard and secure way to handle this process. Therefore, the correct thing to do is supply the encryption key in a.boto configuration file and use sudo to upload the files. Question 96. Your customer wants to capture multiple GBs of aggregate real-time key performance indicators, KPIs, from their game servers running on Google Cloud Platform and monitor the KPIs with low latency. How should they capture the KPIs? A. Store time series data from the game servers in Google Bigtable and view it using Google Data Studio. B. Output custom metrics to Stackdriver from the game servers and create a dashboard in Stackdriver Monitoring Console to view them. C. Schedule BigQuery load jobs to ingest analytics files uploaded to cloud storage every 10 minutes and visualize the results in Google Data Studio. D. Insert the KPIs into Cloud Data Store entities and run ad hoc analysis and visualizations of them in Cloud Data Lab. Okay, this is a question about monitoring and observability. The key requirements here are to handle a real-time stream of performance data, or KPIs, and to be able to monitor that data with very low latency. With that in mind, let's look at our options. Let's start with option A. While Cloud Bigtable is a great database for storing large volumes of time series data, using Google Data Studio for viewing is not the best choice for low-latency, real-time monitoring. Cloud monitoring is the purpose-built tool for that. Next, option C suggests a batch processing approach using BigQuery. This is incorrect because loading data every 10 minutes introduces a significant delay, which violates the real-time and low-latency requirements of the question. Option D is also not a good fit. Cloud Data Store is not optimized for time series data, and Cloud Data Lab is a tool for interactive data science, not for creating real-time monitoring dashboards. This brings us to option B, which is the correct and Google-recommended solution. This approach uses the right tools for the job. First, your game servers can output custom metrics directly to cloud monitoring, which is designed to ingest this kind of data with very low latency. Second, once the data is in cloud monitoring, you can easily create a dashboard in the console to visualize and monitor your KPIs in near real time. This is exactly what the cloud monitoring service is built for. Therefore, the best way to capture the KPIs is B. Output custom metrics to Stackdriver from the game servers and create a dashboard in the Stackdriver Monitoring Console to view them. Question 97. Your company wants to start using Google Cloud resources but wants to retain their on-premises Active Directory domain controller for identity management. What should you do? A. Use the Admin Directory API to authenticate against the Active Directory domain controller. B. Use Google Cloud Directory Sync to synchronize Active Directory usernames with cloud identities and configure SAML SSO. C. Use Cloud Identity Aware Proxy configured to use the on-premises Active Directory domain controller as an identity provider. D. Use Compute Engine to create an Active Directory AD domain controller that is a replica of the on-premises AD domain controller using Google Cloud Directory Sync. Okay, this is a very common identity management question for companies moving to the cloud. The goal is to let employees use their existing company password, which is managed by an on-premises Active Directory, to access Google Cloud services. With that in mind, let's look at our options. Let's start with option A. The Admin Directory API is a tool for managing users and groups that already exist within Google's system. It's not a tool for connecting to and authenticating against your on-premise Active Directory. Next, option C suggests using Cloud Identity Aware Proxy, or IAP. IAP is a powerful security tool for protecting access to specific applications, but it's not the primary service you would use to integrate your entire Active Directory with Google Cloud for general access. Option D is also incorrect. It suggests creating a replica of your Active Directory domain controller on a Compute Engine VM. While this is a valid architecture for extending your AD, the statement incorrectly says you would use Google Cloud Directory Sync to do the replication. GCDS syncs users and groups, not the domain controllers themselves. This brings us to option B, which describes the correct and recommended two-part solution. First, you use Google Cloud Directory Sync. This is a specific tool provided by Google that reads your on-premise Active Directory and synchronizes your users and groups into Google Cloud Identity. Second, you configure SAML SSO, which stands for Single Sign-On. This sets up a trust relationship where Google Cloud trusts your on-premise Active Directory to handle the user login process. This combination allows you to manage your users in one place, your on-prem AD, and lets them use their familiar corporate password to access Google Cloud. Therefore, the correct approach is B. Use Google Cloud Directory Sync to synchronize Active Directory usernames with cloud identities and configure SAML SSO. Question 98. You are running a cluster on Kubernetes Engine GKE to serve a web application. Users are reporting that a specific part of the application is not responding anymore. You notice that all pods of your deployment keep restarting after 2 seconds. The application writes logs to standard output. You want to inspect the logs to find the cause of the issue. Which approach can you take? Review the Stackdriver logs for each Compute Engine instance that is serving as a node in the cluster. B. Review the Stackdriver logs for the specific GKE container that is serving the unresponsive part of the application. C. Connect to the cluster using cloud credentials and connect to a container in one of the pods to read the logs. D. Review the serial port logs for each Compute Engine instance that is serving as a node in the cluster. Okay, this is a very common troubleshooting scenario in Kubernetes. The key symptom is that the application pods are in a crash loop, restarting every 2 seconds. This makes it impossible to connect to them directly to see what's wrong. With that in mind, let's evaluate our options. Let's start with the options that look at the wrong level of logs. Options A and D suggest looking at the logs for the Compute Engine instances, either the system logs or the serial port logs. This is incorrect because those logs are for the underlying virtual machine, not for the application running inside a container on that machine. You won't find your application's error messages there. Next, let's look at option C, which suggests connecting directly to a container in one of the pods. This is incorrect because it's practically impossible. The pod is only alive for 2 seconds before it restarts. By the time you could get a connection, the pod would be gone. You need a way to see the logs from before the crash. This brings us to option B, which is the correct and recommended solution. Google Kubernetes Engine is tightly integrated with cloud logging, which was formerly part of Stackdriver. Any logs your application writes to standard output are automatically collected and sent to cloud logging. Because these logs are stored centrally and persistently, you can go into the cloud logging console, filter for your specific container, and see the error messages that were printed right before it crashed. This is the only reliable way to debug a crash looping pod. Therefore, the correct approach is B. Review the Stackdriver logs for the specific GKE container that is serving the unresponsive part of the application. Question 99. You are using a single Cloud SQL instance to serve your application from a specific zone. You want to introduce high availability. What should you do? Create a read replica instance in a different region. B. Create a failover replica instance in a different region. C. Create a read replica instance in the same region, but in a different zone. D. Create a failover replica instance in the same region, but in a different zone. Okay, this question is about configuring high availability for Cloud SQL. The key here is to understand the difference between a read replica and a failover replica, and also the difference between high availability within a region and disaster recovery across regions. With that in mind, let's look at our options. Let's start with the options that place the replica in a different region, which are A and B. These describe a disaster recovery strategy, which is for surviving the failure of an entire region. The question is asking for high availability, which is about surviving the failure of a single zone within a region. So, both A and B are incorrect for this specific goal. Next, let's look at option C. It correctly places the replica in a different zone within the same region, which is the right location for high availability. However, it suggests using a read replica. A read replica is used to offload read queries to improve performance, but it cannot be automatically promoted to become the new master instance in case of a failure. Therefore, it does not provide high availability. This brings us to option D, which is the correct solution. To configure high availability for Cloud SQL, you create a specific failover replica. This replica is kept in sync with your primary instance. You must place this failover replica in a different zone, but within the same region. If the zone containing your primary instance fails, Cloud SQL will automatically promote the failover replica to become the new primary, allowing your application to continue running with minimal interruption. Therefore, the correct way to introduce high availability is D. Create a failover replica instance in the same region, but in a different zone. Question 100. Your company is running a stateless application on a compute engine instance. The application is used heavily during regular business hours and lightly outside of business hours. Users are reporting that the application is slow during peak hours. You need to optimize the application's performance. What should you do? Create a snapshot of the existing disk. Create an instance template from the snapshot. Create an auto-scaled managed instance group from the instance template. B. Create a snapshot of the existing disk. Create a custom image from the snapshot. Create an auto-scaled managed instance group from the custom image. C. Create a custom image from the existing disk. Create an instance template from the custom image. Create an auto-scaled managed instance group from the instance template. D. Create an instance template from the existing disk. Create a custom image from the instance template. Create an auto-scaled managed instance group from the custom image. Okay, this question is about taking a single, standalone application and making it scalable and resilient on Google Cloud. The problem of being slow during peak hours is a classic sign that a single server can't handle the load. So we need a way to automatically add more servers when needed. The standard solution for this on Compute Engine is to use an auto-scaled managed instance group. To create a group, you first need a blueprint for your servers, which is called an instance template. And to create that template, you need a master copy of your server's disk, which is called a custom image. With that sequence in mind, image, then template, then group, let's look at the options. Option A is incorrect because you cannot create an instance template directly from a snapshot. You must create an image first. Option B is also incorrect because it's missing a step. You cannot create a managed instance group directly from a custom image. You must use the image to create an instance template first. Option D has the steps in the wrong order. You cannot create a custom image from an instance template. It's the other way around. This brings us to option C, which describes the correct and logical sequence of steps. First, you create a custom image from the disk of your existing working virtual machine. This image is your golden copy. Second, you create an instance template that uses that custom image. This template acts as the blueprint for all new instances. Finally, you create an auto-scaled managed instance group based on that template. The instance group will now automatically launch new, identical instances from your template whenever traffic increases, solving the performance problem during peak hours. Therefore, the correct procedure is C. Create a custom image from the existing disk, create an instance template from the custom image, and create an auto-scaled managed instance group from the instance template. Thank you for watching. If you found this content valuable, please consider supporting the channel by liking, sharing, and subscribing. Furthermore, if you wish to discuss any of the questions presented, please leave a comment below, and I will respond as soon as I am able. I will be releasing the next video with the remaining questions shortly. I wish you all the best on your exam.